Welcome, everyone, to level 2 of Drawing Covalent Compounds. This is the assignment for Friday, May 1st, that will be due on Monday, May 4th. Make sure that you've gone back to check the answer key and video for homework 2. Remember, you can find that on your classwork stream. Look for Unit 6 covalent bonding, and there are the answer keys to covalent work. There are answer keys to the homework 1 and homework 2 available under the Unit 6 covalent tab. The other tool that we're going to be using in this lesson is from your resource library. Remember, the periodic table is really helpful. So if you don't have your paper copy, there's an electronic copy here. This assignment also has two attachments. One of them is the explanation of a checklist of things to do. You can go back and look at homework two's checklist also if you need some help. And there's also a Google Slides component that you're going to be editing. I'm going to do the first couple of ones with you, and then you're going to do the remaining ones for homework. Remember, all of these problems can be done on a separate piece of paper, and you can take pictures. I realize that Google Slides is really clunky to use for this. If we were doing it in class, I would have you do it on paper with paper and pencil. So make sure that you're using whatever one works best for you. The only reason that I'm showing you on Google Slides is because there are some folks who can't take pictures. So if you feel more comfortable doing it by hand and then just taking a picture to submit, totally fine. All right, let's begin. These ones are getting a little bit harder, but the steps are exactly the same. So figure out what the compound is and how many atoms you need of each. I need 1 carbon and 2 oxygens, so I'm going to pause and do those quickly. The next step after getting all of your atoms there, so I have 1 carbon and 2 oxygens, are to make sure that you have the correct number of valence electrons around each atom to start. Carbon should have 4 valence electrons, and oxygen should have 6 valence electrons. So I'm going to put those valence electrons around my atoms right now. Okay, now I have all of my valence electrons around. Remember, when placing them, you give 1 to each side before you start doubling up, which is why carbon, which only has 4, has 1 on each side, and oxygen, which has 6, has 1, 2, 3, 4, and then we doubled up 5, 6. Notice that on both of these oxygens, I've put the single electrons on the side that's closest to the carbon. So these ones have the singles on that side, these ones have the singles on that side. It's because now I'm going to start connecting the dots to make the bonds. And you'll see that I have 1 bond that I can connect here, right? That's the closest one. And I have another bond that I can connect here. That's the next closest one, right? So I'm connecting these 2 electrons and these 2 single electrons. The electrons never like to be by themselves. So once we have them paired, now it's just like these pairs, only this pair is being shared between the atoms. But you'll notice that we still have those unshared electrons um, that are single electrons by themselves, and they're lonely. So we're going to make more bonds that connect oxygen and carbon so that we're sharing these electrons also. So I'm going to connect the dots there. And these ones are a little bit farther away, so I'm going to make one that's a little bit trickier. We're going to clean it up in just a second. So this electron, I'm going to draw a line connecting to that dot. So it's a little bit messy, but you can see now all of the electrons are paired, either being unshared, or the 2 single electrons from different atoms are now connected to each other in a bond. So let's go back to our checklist and see how we're doing. On our checklist, we have the correct number of atoms, we have the correct number of electrons total. So once we've drawn our compound, we want to make sure that all of our total electrons are still there. We started out with 4 from carbon. So I'm going to just count electrons up here. 4 from carbon plus 6 from each oxygen, right? This 4 is from the carbon, this is from one oxygen from another oxygen. So 4 plus 6 is 10, plus 6 is 16 electrons. Let's count and make sure that we have 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. We've got all of our electrons. Great. Now, we want to make sure that, so we counted all the electrons. Each bond counts as 2. Positive and negative charges, we'll go to that in just a second. Make sure that all atoms satisfy the octet rule. Every atom should have 8 electrons. It can either be a shared pair in a bond or an unshared pair. So 2, 4, 6, 8, right? That oxygen has all 8 electrons now to complete the octet rule. This carbon has 2 in that shared pair, 2 in that shared pair, 2 there, and 2 there. Carbon also has 8. It's okay if you count the electrons twice because that bond means that the oxygen has them and the carbon has them. So each of these atoms needs to have 8, either in lone pairs or shared. And it's okay if you count the shared pairs twice if you're doing it for the individual atom. So this shared pair counts for both oxygen and for carbon. This oxygen also has 8. 2, 4, 6 in that pair, 8 from that pair. All right, so now I'm going to pause and clean up this structure. All right, so this is my cleaned up structure of CO2. 1 carbon, 2 oxygens, a total of 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. And this oxygen has 8, 2, 4, 6, 8, because you're counting 2 in each of those pairs. Now I'm going to count for carbon. 2, 4, 6, 8. Yep. Now I'm going to count for oxygen. 2, 4, 6, 8. Atoms are correct. Electrons are correct. Octet rule is satisfied. Now let's try a harder example. NO2 with a -1 charge. This means that when we're doing our little electron count, it's a little bit different. So I'm going to count the electrons here for you. So nitrogen has 5 electrons plus 6 for one oxygen plus 6 for the other oxygen. Now the -1 charge means that there's an extra electron, meaning remember that electrons have a negative charge. So if it has a -1 charge, that means it has 1 extra electron. So in our total electron count, we're going to add 1 more. So that means we have 11 plus 6 is 17 plus 1 is 18 electrons total. All right. So as we're making our structure, we need 1 nitrogen and 2 oxygens. And because there's just 1 nitrogen, I'm going to put it in the middle. Now I'm going to start making this structure and come back in a moment. All right, so I've put in all of my electrons. Each oxygen has 6, 2, 4, 5, 6, 2, 4, 5, 6, and the nitrogen has 5, 2, 3, 4, 5. Now I'm going to start connecting the dots to make my bonds. So I'm going to connect these 2 dots here. I'm going to connect these 2 dots here. Connect these 2 dots here, right? This is my double bond. I'm trying to make all of these single electrons have a friend, have a pair. But notice, now that I've connected all those dots, I still have 1 dot that's hanging out by itself. And this is why this molecule has a -1 charge. Remember, we should have 18 electrons total. 2, 4, 6, 8, 10, 12, 14, 16, 17. That 18 electron comes from an extra electron that's added to the structure. We add it in a place so that this that electron that oxygen had by itself now has a friend. So that means that this structure looks like this. We're going to go back and check. We have the correct number of atoms. Yep, 1 nitrogen, 2 oxygens. We have the correct number of valence electrons, right? Each bond has 2, and we're adding in that extra 1 for the negative charge. So 18 total. 2, 4, 6, 8, 10, 12, 14, 16, 18 total. And we're going to make sure now that all of them satisfy the octet rule. 2, 4, 6 plus 8 for this oxygen. 2, 4, 6, 8 for that nitrogen. 2, 4, 6, 8 for this oxygen. I'm going to clean this up so you can see what it looks like a little bit more clearly. All right, on the bottom here, you can see what this looks like. Remember, we need to have 1 nitrogen, 2 oxygens, 18 electrons total. 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons total. And we have 1 bond here, and we have 2 bonds here. And the octet rule, 2, 4, 6 plus this 8, 2, 4, 6, 8 for that nitrogen, and 2, 4, 6, 8 for that oxygen. Everybody's happy. To show that this whole thing has a -1 charge, I'm going to insert a text box to show that this one has a -1 charge. I'm going to put that right next to it to show that this has a -1 charge. All right, let's try the other direction. NH4 with a +1 charge. We do the same things, right? We have our nitrogen and our hydrogens. I'm going to put those in place. Now that I've put those in place, let's go back and do the step that I missed for counting the electrons. So let's put in a text box to count electrons. So we have nitrogen that has 5 electrons. We have hydrogen that has 1 electron. So I'm going to count that. +1 hydrogen, +2 hydrogens, +3 hydrogens, +4 hydrogens. Right? So 5 for nitrogen, 1 for each hydrogen. This +1 charge means that something has happened to the electrons. Remember, the electrons have a negative charge. So if we have a +1 charge, it means that we've lost an electron. Remember, we've lost a negative charge, so it becomes more positive. Once you get rid of all those negative feelings, you become more positive, more happy. So that means that that +1 charge here means that we've lost an electron from our total. So this -1 charge is because of the charge. So be careful. So now as we're keeping track of our charge, our total charge, we have 5, 6, 7, 8, 9, -1 is 8. So our total electrons are going to be 8 electrons total. So let's start placing them. All hydrogens have 1 electron. I'm going to put those in now. All my hydrogens have 1 electron. Nitrogen should have 5 electrons. I'm going to put those in now. Okay, so my hydrogens each have 1 electron, and my nitrogen has 1, 2, 3, 4, 5. But remember, we should just have 8 electrons total. So what I'm going to do is take away one of the nitrogen electrons. Oops, not take away 2, just 1. Take away one of the nitrogen electrons. So that means that we should have 8 electrons total. 1, 2, 3, 4, 5, 6, 7, 8. And you're probably thinking ahead to say, I see where the bond should be. I'm going to connect all those dots. Let's do that now. Looking good. All of those single dots have been connected. So now they're happy in pairs being shared between each of those atoms. Okay, let me clean this up so we can see this a little bit better. All right, let's double check. So we have 1 nitrogen, 4 hydrogens. Check. There should be 8 electrons total. 2, 4, 6, 8. All of those electrons are in shared bonding pairs. Each atom should satisfy the octet rule. Nitrogen has 2, 4, 6, 8 that are being shared. But this hydrogen, wait, all the hydrogens just have 2. Is that okay? Yes. Hydrogen is the exception. It's satisfied with just 2 electrons. Remember, hydrogen has 1 electron by itself, but because it's in the smallest period, it's full with just 2, like helium. So now hydrogens become like helium. Good job. So hydrogen has 2 electrons each. Very nice. But remember, it had a charge. We have to show that we lost an electron, right? There would have been too many otherwise. 9 electrons. Oh, that's not an octet. So we want to show that this one has a charge by putting in our text box with the charge. +1 is our charge. And then we're done. All right. Good luck. Give these ones a try. Email me if you have questions.